Today, we're going to talk a lot about using your graphing calculator. Now, by definition, these are graphing calculators, which means they can do a lot with graphing. And that's mostly what we're going to deal with today. So, turn it on. To graph, you go to y equals. And then you type in the equation you want to graph. Let's say it's negative 2x plus 8. And then what a lot of students will do is hit the graph button. And my personal opinion is that's not a great idea. The reason it's not a great idea is I really don't know what the scaling is on my graph. I don't know what each of these tick marks counts for, and I got something really weird going on the y-axis here. So I must have had my calculator set up in some weird viewing window in the past. So if I just hit the graph, I really don't know what I'm looking at. Instead of hitting graph, what I suggest you do instead is go zoom, and then go down to number 6, which is zoom standard. Oops, I went one too far. So what zoom standard does, it makes it so that each of these tick marks counts as 1. So it's 1, 2, 3, 4, 5, 10 across, 10 that way, and also 1 in this direction. 1, 2, 3, 4, 5, 6. So we can see the graph. Okay? The other thing that the calculator does automatically when you type something into y equals is it builds a table for you. You'll see table here on the same button as graph. So if I go to the table, you'll notice that it's automatically plugging numbers in for me, 0, 1, 2, 3, 4, 5, 6, and I can go back and I can plug in negative numbers, so on and so forth. Now, in a lot of applications, you might not want to plug in nice numbers like 0, 1, 2, 3. You might want to plug in big numbers like 15, 20, 25, or maybe you want to plug in little decimals depending on the problem. So what I like to do for table is I like to go into the table set, which is on the same button as window. Second, table set, and I like to come down here and make the independent ask. So I'm just hitting enter there. Now when I go back to my table, it seems like nothing shows up, but notice it has x equals, and it allows me to type in anything I want. So if I want to plug in 50, I can plug in 50. If I want to plug in negative 1.365, I can plug in negative 1.365. So this is my preference. I like my table set up this way, and then if I need to plug in numbers like 1, 2, 3, 4, 4, I can do that quickly too. And you can just come back up here and delete whichever ones you don't want to start all over. So that's my choice of how I like the table to be. How you want to use it is up to you. All right, back to the graph. You can also use the graph to plug in numbers. And what I mean by that is I can push this trace button, and it's going to put a cursor on the graph. You'll see it here, and it'll tell you this is the point 0.8. I can use my arrows to move around if I want, but I really can't control what numbers it's plugging in. So let's say I wanted to plug in exactly 1.5. Well, as you can see from using the arrows, I can't do that. But what you can do is come down to the screen, type in 1.5, enter, and it'll plug it in for you. When you plug in 1.5, you'll see your y value is 5. The only weakness of this is I don't think you can go off the screen. Like I don't think I can plug in x equals 12, for example, because my window, remember my x values only went as far as 10. Where in the table, I can type in any numbers at all that I want. All right, quit. Another graph. Y equals minus x squared plus 25. Push the graph button, and I don't see a very good graph. What I mean by I don't see a very good graph is it appears as though the graph is going up, turns around somewhere, and comes back down. But I can't see where that's happening. I can't see where that turnaround point is happening, and I'd really like to see that. So what that means is my graph needs to go higher. So to do that, we push the window button. My x's are okay. I can see left and right just fine. So my x's can stay at -10 and +10. My y min can stay at -10. That's okay. But I think I want my y max to go higher. So I'm going to try maybe making it 20. Let's see what we look like now. All right, better. We can almost see the top, almost see where it's turning around, but not quite. But notice what happened now. Look how many little tick marks there are along here. All right, so let's go back to window. Let's make this go up to 30. Now, how do we change the little tick marks? That's the X scaling. What's happening is the calculator was trying to draw 20 little tick marks all the way up because we told it we want each tick mark to be worth 1. I'm going to change that so that each tick mark is now worth 3. All right, but now you need to realize what this means. This means these on the x-axis are now 1, 2, 3, 4, 5, but these on the y-axis are 3, 6, 9, 12, so on and so forth. So when you go to draw your graph on paper, it is absolutely imperative that you draw scaling. If you take your paper, if this were a question on a quiz, if you take your paper and you draw that, I'm going to give you very, very little credit because it doesn't really tell me any information. You need to draw these tick marks and tell me that these are 1, 2, 3, and then you need to draw these tick marks. Let's see, this goes up, I forget how high it went, but you could count them out here. You need to tell me these are 3, 6, 9. You absolutely positively need to give me scaling. Without scaling, I don't know if these tick marks are 1, 2, 3, or 3, 6, 9, or 50, 100, 150, so on and so forth. And it makes a huge difference in knowing that or not knowing it. Okay? All right, I'm going to clear out and give another graph here. Actually, how about we just put a second graph on this page? Let's go 2x plus 1. What I want to know is I want to know where these two graphs cross. It looks like they cross right here. And it looks like there's a spot just off the screen where they cross again. So we would need to fix our screen to be able to do that. So really what we're looking at here is we're solving the equation minus x squared plus 25 equals 2x plus 1. And we can see from the graph that it looks like this equation has two answers, there and there. Now to see this one, we need the graph to go just a little bit lower. So I'm going to go back to my window and change that to be minus 20. And now we can see both places where they cross. All right, so to find the answers, there's two of them. We go into this calculate menu. Second, calculate. We go down to number 5, intersect. Intersect is a fancy way of saying where do the graphs cross. Intersect. It asks us, is this the first curve? Yeah, so I hit enter. Then it jumps down to the line. It says, is this the second curve? Yes, I hit enter. Then it asks for a guess. So if I want to find this one over here, I move over close and I hit enter, and it tells me the answer is 4. All right, that was happy. I didn't necessarily know that these would come out to be nice numbers. I expected them to be ugly decimals. I got lucky. I made up two equations. I made up an equation that came out to nice answers. All right, now we got to find the other spot. To find the other spot, we do the same thing again. We go calculate, down to intersect. Oops, one too far. Once again, it asks, is this the first curve? The answer is yes. Is that the second curve? The answer is yes. Now it wants a guess. Got to get close. You don't have to get that close usually. It tells us the other answer is -6. Okay, you might be wondering, why does it ask, is that the first equation, is that the second equation? Because you might have more than 2 typed in. You might have 3 or 4 typed in, and it needs to know which 2 you're trying to work with. All right, let's clear these out. Now let's say I asked you to solve the equation, let's say it was x cubed minus 3x minus 1 equals 0. All right, well, I would type that in here. I would type in x cubed minus 3x minus 1. Zoom 6 to go back to my usual viewing window. And this time I see that there are 3 answers. I want to know where this is equal to 0 is the same as asking where are the x-intercepts. There's 1, 2, 3. All right, to solve, we go calculate. This time we're looking for zeros. So notice there's 2 different situations for solving equations. If you have stuff on both sides, like we did on this first equation, you use the intersect option. If you only have stuff on one side and equal to 0, you use the 0 option. All right, so let's say we're trying to find this point right here. It says, is this a left bound? Which means it just wants us to be somewhere left of that point. We are left of it. Enter. Wants a right bound. So we move over so that we're right of that point somewhere. Notice the up and down doesn't matter. It's really the left and right. I hit enter. It asks for a guess. Hit enter. So one of the answers is x equals, we're going to call it 1.88. Rounding to 2 decimal places. All right, then we got to find the other 2. We do the same process again. 0. Now I'm trying to find the one in the middle. I want to go left of it, but I don't want to go left of the other one. So I'm going to go to that spot right there, hit enter. Move over a little bit here, hit enter. Give it a guess. X equals minus 0.35, rounding to 2 decimal places. And then one more. Calculate the 0 one more time. Left of that one, right of it, but again, don't go right of the other one there. And a guess. X is negative 1.53. All right, I'm at about my time limit for what I'm allowed to make for a video, so I'll close this video off and then I'll start another one.